Hey, this is Mr. Krieger. Welcome to Algebra 2. We're going to start with Lesson 1. And the thing that I want you to keep in mind is that the first few pages, multiplication of polynomials and division of polynomials, we're going to do that live. So what you're going to do starting on the video is this. We're going to start with simplifying radicals. You should just have this page in front of you. It's going to be a little hard for you to see this on the video, but I'm going to write large, so it should be no problem for you to follow along. So what I'm going to do in this video today is I'm going to go over simplifying radicals, both square roots and cube roots, okay? So in order to do this, and again, you've done this in Algebra 1 too, is you should know your perfect squares. So, starting with 1 is a perfect square. And the way we get 1 is it's 1 squared. The next perfect square is 4, and that's because 2 squared is 4. And then you get 9 and 16, 25, 36, 49, 64, etc. And that's, 3 squared, 4 squared, 5 squared. And keep in mind that in order to generate this list of perfect squares, you just take the numbers in order, 1 through whatever, and square them, and you'll get your perfect squares. Now, it's with these perfect squares that we can take a square root. So the first example, square root of 81, I'll write it larger for you, is just asking what number times itself will give you 81. So we take a look at our list. Oh, it's not there yet, and I'll tell you why, because it would be the very next number on the list. 81 comes after 64. What is the square root of 81? It's 9. So the square root of 81 is 9, okay? And we could do another perfect square. Let's say there's another one that's not on the list, square root of 100. What do you think that would be? Obviously, it's going to be 10. So that's how you simplify square roots with the square roots of perfect squares. How about simplifying a square root that has a variable in it? Let's take a look. Well, the square root of x, that's not a perfect square. There's nothing you can do to simplify that. The square root of x is just the square root of x. But the square root of x squared is actually equal to x. If you think about why that is, it's because what times itself is x squared? X times x is x squared. So the square root of x squared is x. In fact, just give you a little more on that. Let's take a look at something. So let's take a look at x square root of x to the 4th. So we think to ourselves, okay, what is the square root of x to the 4th? Well, what times itself is going to give us x to the 4th? X squared times x squared is x to the 4th, because in the case of variables with exponents, we're dealing with adding their exponents. Watch this. Square root of x to the 6th. We know when you multiply variables with exponents, it's a matter of adding their exponents. So x cubed times x cubed is literally 3 plus 3 is 6, x to the 6th. So what times itself will give us x to the 6th? X cubed times x cubed, because you would add the exponents giving you x to the 6th. Let's do one more. Square root of x to the, let's do 10th. X to the 5th times x to the 5th is x to the 10th, because 5 plus 5 is 10. So that kind of brings us to a rule. And the rule is if the exponent is even for a variable, then what you're going to do to find by the way, the answer to this is x squared, the answer to this is x cubed, the answer to this is x to the 5th, and you just literally need to take half that exponent, and you've got the answer. So the square root of x to the 10th is x to the 5th. The square root of x to the 6th is x to the 3rd. Now the next question is, what happens if the exponent is an odd number? Okay, so let's take a look. I'll write this larger. Square root of x squared is just x, because x times x is x squared. How about x to the 13th? Let me write that larger for you here so you can see it. So half of 13 is 6.5, but we don't want any decimals or fractions in our answer. So what we're going to do is we're going to break this up into two parts. an even exponent and x to the first. So we're going to get x to the 12th and x. Literally take the 13, reduce it by 1 to get 12. So that's the even exponent. And then this is the additional 1. So 12 and 1 make 13. Remember, if you multiply these, you add exponents. So 12 plus 1 is actually 13. Square root both of those, and that will give you square root of x to the 13th. Now, we've just learned how to take the square root if the variable's even, an even number like 2 or 4 or 12. You literally just take half the exponent. So you got x to the 6th. And this part is stuck because this square root of x is just the square root of x. It's stuck. You get x to the 6th square root x, and that is the simplification of the square root of x to the 13th. All right, here are some other problems. Here's a combination of numericals and variable. So I'll write these a little larger. Square root of 36x squared. 36, the square root of that is 6. X squared, the square root of that is x. So it becomes 6x. How about 36x to the third? Well, the 36 part, that's just going to become a 6. And the x to the third part, you're going to break that into x squared. So there's an x squared here, and then another radical x. Kind of like what we did over here, except this time we have to get the number to add up to 3. So we're going to use 2 and 1, 2 being the even number. Square root of x squared is x. So this, and the square root of 36 was 6, so you get 6x. And then you're still going to be stuck with a radical x. Let me show that to you one more time so it makes a little more sense to you. Watch. We have the square root of 36x to the third. You can break these up into pieces. Rad 36, rad x to the third. This is just going to become a 6. The x to the third, though, you're going to have, that's an odd number, so you're going to have to break that into 2 parts. An x squared part, literally reduce that by 1. And then the x to the first part. Now, the square root of x squared is x. That becomes 6x. And this just becomes the square root of x. And that's how you get this answer. Okay? And this one was 36x to the fourth. Square root of 36 is 6. Square root of x to the fourth. That's an even exponent. So we literally just do half. We get x squared. All right. So I'm going to go through a couple of these. 49x to the fifth. So we got radical 49. The x to the fifth, I'm going to break it into x to the fourth and x to the first, or just x. Square root of 49 is just 7. 7 times 7 is 49. X to the fourth, we know the square root of that is x squared. And the square root of x, we're just going to be stuck with the square root of x. Next one is all perfect squares. Square root of 49x to the 12th is going to be 7x to the 6th. Square root of 49 is 7. Square root of x to the 12th. Remember, we just do half the exponent. So notice you deal with the numerical coefficient of 49 by using one of the numbers up here. But in terms of the exponent on the variable, if it's an even exponent, in this case 12, you just take half of it. So you're not doing literally like one of these numbers. You're just doing half if it's even. And let's just do one more of these. Square root of 49x to the 19th. So the square root of 49 is just 7. X to the 19th, we should break that into x to the 18th and the square root of x. Remember, reduce that 19 by 1, put that into a radical, and then the leftover x will go by itself here. That makes 19. 18 and 1 is 19, but that's the perfect square. That's going to be x to the 9th. So you got 7x to the 9th, and then you got the square root of x. All right? All right, I'm just going to move on from here. I think you get the idea. Okay, so now we're going to talk about simplifying radicals. First, just the numerical ones. And in order to do this a little more easily, I'm going to do it on a separate sheet of paper for you. All right, so this is the square root of 18. Now, that is not on this list. We're looking for 18 on this list, and 18 is not on this list. We got 1, 4, 9, 16, 25. 18 would be in there. It's not a perfect square because 16 is a perfect square, and the next perfect square is 25. 18 is not there. So what do? Well, you're going to look for the perfect square that goes into 18. Now, there's only one that goes in, and it's 9. Now, if you had multiple choices, in fact, sometimes you'll see when we move ahead, there will be times when there will be many choices for perfect squares that go in. Pick the largest one that goes in. Here, it's not an issue. We'll see when it becomes an issue soon. So, square root of 18 breaks up into the square root of 9 times the square root of 2. 9 times 2 is 18. That is the perfect square part. and then the leftover factor, because you need whatever else will multiply with 9 to get you 18. Now, since the square root of 9 is a perfect square, it's going to be 3. That's going to go here, 3 on the outside. The square root of 2 is not perfect square. It's just going to be stuck like that. So you get 3 square root 2. That's the simplification for the square root of 9. So, okay, let's take a look at these. Rad 20. So I'll make that a little larger. I'll do it over here. The perfect square that goes into it is going to be 4. It's the only perfect square that goes into rad 20. So you're going to get 4. And the other factor of 20 is 5, because 4 times 5 is 20. Square root of 4 is just 2. You get 2 square root of 5. Okay. Next problem, square root 75. Let's take a look over here. 25 goes into 75. So we're going to break that down to 25. And 25 times 3 is 75. So square root of 25 is just 5. You get 5 radical 3. That's simplified. All right, let's take a look. Square root of 90. Let's see if there are any other. No, only 9 goes into 90. 9 and 10. 9 and 10. Square root of 9 is 3. 3 rad 10. Okay? And then we got another situation over here. 2 rad 9x. I'll put that one over here. 2 rad 9x. I could make this 2 rad 9 rad x. Each of these can get its own radical. This is a perfect square. It's going to be 3. And 2 times 3 is 6. So you get 6 rad x is how this number 6 simplifies. Okay, let's take a look down here. No, I wanted to keep this here. All right, next problem. 1/3 rad 72 x to the third. So this is problem number 7. 1/3 rad 72 x to the third. Now here's a situation where there are a couple of choices of numbers of perfect squares that go into 72. 4 goes into 72. 4 goes into 72 18 times. Okay. 36 goes into 72 2 times. So what are you going to choose? Pick the bigger number, the 36. All right, so here's what I'm going to do. I'm going to take the 1/3 square root of, 36. That's the perfect square. Square root of 2. Now the x to the third, I'm also going to break that down. That's going to be x squared and then x. Let's see what we got. 36 becomes 6. Square root 2, not going to simplify. Square root of x squared is x, and square root of x squared is x, but the square root of x is just the square root of x. We also had a 1/3 in front. These numbers can be multiplied. 1/3 of 6 is 2. And this x should come next. You might say, why should that come next? Because the radical stuff should always be on the furthest most to the right. So we have a 2 in the radical and an x. This x is in the radical. We can put those back together. 1/3 rad 72 x cubed becomes 2x square root 2x. Okay, let's see what else we got here. We got, get another sheet of paper. 4 square root of 63 x to the 4th y to the 7th. Okay, perfect squares that go in there. There's only one, 9. So let's write that down. We got a 9 and we got a 7. And I'll put x to the 4th here. And we'll break up the y to the 7th to y to the 6th and a y. Let's simplify what we can. This becomes a 3. This is going to stay rad 7. This is going to become x squared. This is going to become y cubed. And this is rad y. Numbers go first. So 4 times 3 is 12. Numbers that aren't in radicals. Things in radicals, that's going to go at the end on the right end. And the variables will go in the middle. So that's going to go here, x squared y cubed. And then in here, we got 7y. And that's how you simplify that. Okay, and let's do the last one. We got -3 minus the square root of a to the 16th over 49. A to the 6th, that's not a 9, that's an a. A to the 16th over 49. So let's simplify this. These are all perfect squares. So this is just going to become a to the 8th over 7. You got -3 minus a to the 8th over 7. Now, if you want to get this as one fraction, we're going to need a common denominator. A common denominator would be 7. So this fraction, right, this number right here, I'll put it over 1. And then I'll multiply the numerator and denominator by 7 to get a common denominator of 7. So that's going to give me negative 21 over 7 minus a to the 8th over 7, which gives me a final combined answer of negative 21 minus a to the 8th over 7. Okay? All right, let's move on. Adding and subtracting square roots. So when it comes to adding and subtracting, you can't add any radicals unless they have the same radicand, the same number under the radical, or the same thing under the radical. In this case, I'll write this a little bit larger for you. We got 7 rad 11 plus 3 rad 11 minus rad 11. These are all the same. You can combine them by combining the numbers in front, the coefficients. You got the 7, you got the 3, and you got this. Well, this is really a minus 1. This is a minus 1 rad 11. 7 and 3 is 10. Minus 1 is 9. That becomes 9 rad 11. Okay? Here we got something different. I'm going to rewrite this on another sheet of paper to make it larger. Rad 48 plus rad 12 minus rad 3. Now, these are not the same. You can't combine them. But if we simplify them and they happen to have the same radicands, then we can combine them. So we have to simplify it first to see. Let me get this sheet underneath. All right, so rad 48. We got to find a perfect square that goes into rad 48. Let's look at our perfect squares again. We got, let's see, 4 is the only one. 4 actually, let's see, no, 16. 16 goes into 48 3 times. So that's going to become rad 16 rad 3, which becomes 4 rad 3. 12. I'm going to break that into 4 and 3. It's going to become 2 rad 3. And finally, minus rad 3. And that's really like a minus 1. So they're all rad 3s. 4 plus 2 minus 1 is 6 plus 1 is 5 rad 3, which is the answer to this question right here. It's going to be 5 rad 3. And we'll do, let's do one more, but let's do this one. So that's going to be 5 rad 32x minus 2 rad 72x. I wrote it out over here so you can see it a little better. That 32, I'm going to put it in its own radical. And that 72, I'm going to put in its own radical. Then we're going to simplify that radical. 32, we can break that into rad 16 rad 2. And rad 72, we could break that into 36 and rad 2. Okay, so that becomes 4. This is 4, and 5 times 4 is 20. And we're stuck with a rad 2x. Okay, what we got here? This is a negative 2, and that's rad 36 is 6. Negative 2 times 6 is minus 12. Minus 12 rad 2x. They both have the same radicand, the same number here, 2x and 2x. So we could literally subtract these numbers, 20 minus 12. 8 rad 2x is what that last problem simplifies to. 8 rad 2x. All right? Okay, take a look at the next thing. We're going to solve here a radical equation. So this is not too difficult. Let's take a look what we got here. Let me write it larger. You got 4x minus rad 8 equals rad 72. And we're not going to put this into a decimal form. We're just going to simplify the radical. Let's see what we get. Rad 8 breaks down to rad 4 rad 2, which is 2 rad 2. Oh, I'm sorry, this is 4x. 4x minus 2 rad 2. That 72 breaks down to 36 and 2, which is 6 rad 2. Okay, so let me write it over here. So you got 4x minus 2 rad 2 equals 6 rad 2. Add 2 rad 2 on both sides, and you get 4x equals 6 plus 2 is 8 rad 2. Want to get x by itself, divide by 4. We're going to learn more about dividing in another lesson, but 8 divided by 4 is 2, so x equals 2 rad 2, because 8 divided by 4 is 2, 2 rad 2. So that's what we get, x equals. All right, we're up to the next thing, and the last thing for today. Simplifying perfect cubes. Simplifying cube roots, I should say. So what is a cube root? It's something times itself, which will give you the number in question. Like, for example, the cube root of 8 is 2. Why? This is supposed to be a little 3 in there. Cube root of 8 is 2 because 2 times 2 times 2 is 8. And here's how you can generate the perfect cubes. 1 cubed is 1. 2 cubed, as we just learned, that's 8. So when you see cube root 8, you know it's just going to be a 2. 3 cubed is going to be 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4 is 64. 5 cubed is 5 times 5 times 5 is 125. And we'll do one more. 6 cubed, 6 times 6 times 6 is 216. And this goes on, and you can create as many perfect cubes as you want. These are the perfect cubes here. And this number that's in this position right here is called the index, and we're going to deal right now with cube roots, okay? So let's take a look at a problem. Well, let's do a couple of things. So first of all, we're doing an odd root. Odd roots, you can take this odd root of a negative number. Now, you couldn't take a square root of a negative number, and we'll come back to that another time, but I'll just make a quick mention to you of something about that, and that is that when you do the square root of, let's say, -4, there is no number that multiplies to itself that will give you a -4. Now, you might say, I think it's -2. The problem is -2 times -2 is +4. There is no number, when you multiply it by its identical self, that will give you -4. Now, you might say, 2 and -2. But these aren't identical, so that's not a square root. But cube roots are different. We could do the cube root of -8. Because watch this. -2 times -2 times -2 is -8. If you want to convince yourself of that, do this. -2 times -2 is 4. 4 times -2 is -8. It actually works out. So you can take a negative cube root or a -5th root. For here, they're showing you that the 5th root of -32 is -2, and you can check that for yourself. Check that -2 times itself 5 times will give you -32. So you can take the cube root or 5th root or 7th root of negative numbers. You can't take square root or 4th root or 6th root of a negative number, okay? Even roots can't do negatives, all right? And let's take a look at simplifying cube roots. And in order to simplify cube roots, we are going to need the perfect cubes, which I'll keep right over here. Okay, this is asking for the cube root of 32. We're going to have to look at this line of numbers for numbers that go into 32. And the number that goes into 32 on this list is only 8. So we're going to have to use the cube root of 8 and the cube root of 4. 8 times 4 is 32. 8 is a perfect cube. It's 2. So we get 2 cube root 4. That's how cube root of 32 is simplified. Cube root of 48. So we got to figure one of these numbers that goes into 48. So 64 is too big. 27, no good. 8 goes into 48 6 times, right? 8 times 6 is 48. So we're going to do, this is going to be cube root of 8. Cube root of 6, and the cube root of 8 we know is 2, 2 cube root of 6. All right, here we got a cube root of -27c to the 6th. We got something new here. Let me show you what is new. We got cube root of a variable. Let's see how that's different. Let's do the cube root of, let's do x to the 1st. Well, there is nothing that multiplies to itself 3 times that gives you x to the 1st, so this cannot be simplified. How about cube root x to the 2nd? Same problem. Nothing times itself 3 times is going to give you x to the 2nd, but x to the 3rd, you do have a solution. It's x, because x times x times x is x cubed. Now the next successful one that you're going to get is x to the 6th. Because x squared times itself 3 times is going to give you x to the 6th. Do you see what I mean? Now, what about cube root of x to the 4th? You got a problem, because nothing really multiplies by itself 3 times to get x to the 4th. But you could break this down into the perfect cubed, cube root x to the 3rd, cube root x. This part right here is a perfect cube. Cube root of x cubed is x. So you're going to get x and cube root x, which you can't simplify. And let's take a look at one more of these. How about cube root of x to the, let's say, 13th? So what we're going to do is we're going to say, okay, we need an exponent that goes into 13. 3 goes into the number evenly. Well, 3 doesn't go into 13, but going down 1, 3 does go into 12 evenly. So we can simplify that to x to the 12th and x. So you got cube root x to the 12th, because that's a perfect cube. Cube root of x to the 12th is x to the 4th. X to the 4th times x to the 4th times x to the 4th is x to the 12th. Literally, 12 divided by 3 is 4. And then the cube root of x, that's going to be stuck. So this is how you simplify variables in cube roots, where the exponents can be any numbers. So if the numbers are divisible by 3, no problem. You just take this exponent divided by 3, and that's going to be your new exponent on your solution without the radical. If, I'll give you one more example over here. Let's do cube root of x to, let's say, the 17th. You got to think to yourself, all right, what goes into a number less than 17? What does 3 go into? That's less than 17. The next smaller number under 17 that 3 goes into is 15. So you're going to do cube root of x to the 15, and then you're going to have x squared left. So you got cube root x to the 15, cube root of x squared. Cube root of x to the 15 is just x to the 5th, and you got cube root x squared, because there's no other way you're going to get that x squared simplified anymore. Okay, so this becomes x to the 5th cube root x squared. All right, so now we can actually talk about this problem right here. You might have a little hard time seeing it, so I'm going to write a little larger. We got cube root of negative 27c to the 6th. Now that 27, that's a perfect cube, but it's negative, which is okay, because we know that negative 3 times negative 3 times negative 3 is negative 27. And c to the 6th, 3 into 6 goes 2 times. The new exponent on c is going to be 2, negative 3c squared. All right, let's take a look at the next problem. We got cube root of 250 x to the 10th. So the 250 part, let's take a look at our perfect cubes. 250, 125 goes into 250 2 times. So you're going to break that into cube root 125 and cube root 2. Now the x to the 10th, 3 doesn't go into 10 evenly, but 3 goes into 9 evenly. So make that cube root x to the 9th and a cube root x to the 1st. Cube root of 125 is 5. Cube root of 2 we're stuck with. Cube root of x to the 9th is x to the 3rd. And this is stuck, cube root x. You put the number first, 5. You put x to the cubed, anything, the variable next, and then combine all the cube roots inside the last final part, which you're going to get a cube root of 2 and a cube root of x. You can put it all together as cube root of 2x. Let's try one more, and I'm going to do that on a separate sheet so you can see it. This problem here is cube root 54 x to the 5th y to the 12th. Okay, so now we're going to think through this problem. We got to think, okay, 54. What perfect cube goes into 54? 27 does. Break down to cube root 27, cube root 2. X to the 5th. Well, the next largest smaller variable with an exponent will be x to the 3rd. So we're going to have to break that into cube root x cubed, cube root x squared, where 3 and 2 make 5. And the y to the 12th, that's going to be a perfect cube because 3 goes into 12 evenly. Let's see what we get. Cube root of 27 is 3. This cannot be simplified. Cube root of x cubed is x. This cannot be simplified. Cube root of y to the 12th is y to the 4th because 3 goes into 12 4 times. Now we're going to take all the stuff that's not on the radicals, put it together. 3 and x and y to the 4th. Put the cube root stuff together. We got a 2 in there and an x squared there. Okay? And that's how you simplify cube roots. Let's see if there's any more here that are worthwhile doing. They're all very similar. You can do these, of course, for extra practice. And let me just show you what you can do in order to add cube roots. So to add cube roots, you're going to have to, if they don't have the same radicands here, you are going to need to break them down like we did before. So cube root 40, perfect cube that goes into 40 is 8. Cube root 8, cube root 5, which becomes 2 cube root 5. Now this one here, cube root 135, looking at our perfect cubes, 135, 27 should go into 135 evenly. Let's check that out. So 135 divided by 27 is 5. So we're going to get cube root 27 cube root 5. So that's going to give us 3 cube root 5. We're adding these together. So 2 cube root 5 plus 3 cube root 5. We could add the coefficients together. We get 5 cube root 5. Final answer. And this would be something very similar. You simplify these radicands here, just like I have been doing, and you can combine the like terms if they're like terms. All right, now that's the end of the lesson. Your job is to do the homework, which is continues this lesson. Okay, so there are, let's see how many questions. You have 12 questions to do, and take pictures and email them to me.